Did you know by the end of 2022, the BC Energy Step Code will be mandatory across BC for Part 9 residential and Part 3 complex buildings? Buildings will be required to be 20% more efficient than a base code compliant building. Following this benchmark, in 2027, buildings will be required to be 40% more efficient, and in 2032, 80% or net zero energy ready. With City of Penticton being an early adopter of the BC Energy Step Code, some local builders have been stepping up to make their buildings more efficient. Welcome to High Street Ventures' newly constructed Skaha Shores, a multi-family residential building located on the south end of Penticton. This is the first large, complex building in the city that has achieved Step 4 of the BC Energy Step Code for Part 3 buildings and built Green Canada Platinum certification. To learn more, let's speak with Eric Delorme, one of the project leads.
Skaha Shores has successfully met BC Energy Step Code compliance, demonstrating High Street's path to constructing high-efficiency buildings. In 2011, High Street adopted performance-based design and started energy modeling in 2016 as an exercise in benchmarking. At that time, it was found that the current projects were performing around 28% better than their modeled ASHRAE 90.1 2010 reference building. This design practice recommended performance targets and energy budgets to consulting engineers, allowing real creative freedom in their design, providing the proposed performance metrics were met. This design practice aligned well with the intention of the BC Energy Step Code, allowing for fairly seamless transition between NECB standards and Step Code. Performance-based design has really brought the building energy use incrementally down from total energy use intensities, or TUIs, of 120 kilowatt hours per meter squared to 55 kilowatt hours per meter squared over the course of 2 years. Around the same time, High Street started infiltration or air tightness benchmarking, and since then have taken those benchmarks and assigned performance criteria for all future buildings. From the beginning of this project, we'd always targeted Step 4 of the BC Energy Step Code and built Green Platinum certified. With this in mind, preliminary design charrettes were conducted throughout the conception and design phase for the project. This meant paying close attention to envelope details and air barrier strategies that would ultimately contribute to the building's efficiency. In our experience, focusing on any interruption of the air and vapor barrier laid the best foundation to achieve the top tiers of the Step Code. Following Step Code guidelines, we knew we'd need to construct a very airtight building to hit our thermal energy demand intensity target, or our TEDI target. We used a taped sheeting approach for our air barrier system, and knowing that materials for any air barrier system could only take you so far, our focus was on air barrier continuity. With the building envelope, we were able to achieve an effective exterior wall R value of R17 with R22 batt in the wall cavities, and thermal bridging was reduced with 3 inches of continuous rock wool comfort board insulation exterior to the air barrier. Trade adoption and experience for airtight construction was so important in achieving maximum building efficiency. We were lucky enough to use Passive House certified tradespeople working within most key trade groups on this site. We also implemented an orientation program for ensuring air barrier continuity, outlining all major areas where air leakage could occur and how to address those areas before the trades even stepped on site. We tested the air barrier system for the first time during mid-construction, after the air barrier system was built, but before the drywall was installed. It was tested a second time once the project was complete, and both of these tests did comply with the BC Building Code air tightness testing requirements for whole building depressurization to 75 pascals. The mid-construction air tightness testing is an integral part of ensuring envelope performance because it identifies areas of leakage before the air barrier becomes closed off and inaccessible to fix. We also took into consideration orientation and passive cooling strategies throughout the development and site design process. The project forced a north to south orientation of both buildings, and this left passive cooling strategies to light-colored siding, brise soleils above the south and west facing windows, covered balconies to provide shading to the units below, high performance, triple pane argon-filled windows with low E coatings, achieving U values around 0.17 and solar heat gain coefficients of 0.2. Both buildings have centralized and decentralized HVAC systems. The common areas were ventilated through a central heat pump makeup air unit for heating and cooling, and the suites are ventilated through the individual decentralized ERVs coupled with individual fan coils for personal heating and cooling control. The domestic hot water is a decentralized system using 189-liter air source heat pump hot water heaters in each suite. The exhausted cool air from these water heaters also contributes to reducing cooling loads in the warmer months and can be switched from hybrid mode to fully electric during the cooler months to reduce heating demand. Each building is equipped with solar arrays, supplementing the common area's energy demand with 103 megawatts of electricity annually. That's roughly 99 kilowatts per building. At project completion, after final air tightness testing and thermal bridging calculations, the final energy model report was completed following the City of Vancouver energy modeling guidelines for the BC Energy Step Code compliance. This report identified the TEDI being the total energy demand intensity and the 2E being the total energy use intensity metrics to be well within the allowable tolerances for Step 4. With final infiltration rates of 0.08 liters per second per meter squared, this left our TEDI and 2E metrics to be 24.7 kilowatt hours per meter squared and 55.1 kilowatt hours per meter squared, well within the required metric tolerances for Step 4 compliance. Achieving higher levels of energy efficiency at lower incremental project cost really comes down to a level of dedication. If you take the time to teach the on-site staff and trades about how each piece of the puzzle plays into energy efficiency and pay very high attention to detail, then the cost doesn't necessarily need to become a constraint on your current or future projects. Designers, architects, and trades are all accepting these performance standards. And we've been growing our team for the last 5 years with sustainability in mind. And this means that consulting trades, consulting engineers, everybody who's working with us is doing so because they're up for the challenge or because they're willing to put in the time to learn about what it means to construct a high efficiency or high performance building. When our buildings are being tested post-construction, we've been finding that consulting engineers and trades are getting just as excited about the results as we are. And I truly believe it's because they know that they're making a change in the industry, and that's exciting.
The BC Energy Step Code is one of many programs being initiated by the provincial government to combat climate change and reduce emissions. The overall goal for the built environment is sustainability, focusing on energy efficiency and operational affordability, along with occupant comfort, building longevity, lowering greenhouse gases and pollution in the environment. High Street Ventures are one of the many builders across BC making these positive changes for present and future generations to enjoy and prosper.